Okay, I don't know if I told you in the last video, but you probably could be following the PowerPoint that's on Blackboard because it's what I'm doing right now, but more complete with more and with more notes. So supplement this with that PowerPoint if you would like. Okay, so right now we're going to look at just some derivatives where there's more algebra to simplify them in the end. And that's what this slide says. There are going to be, products, quotients, composites, all kinds of things in the same function. So what we're looking at here, you have f of x equals x squared times the square root of 1 minus x squared. Now, I told you a while ago if you could simplify something first to do so, but because this function is in a square root, you can't simplify it. You can't distribute this through, so we're kind of stuck with a product of two functions of x. So we have to use the product rule. And when we go derivative of the first times the second, we'll be fine. But when we go plus the derivative of the second times the first, this is going to be a chain rule. So this is a case where you kind of have a chain rule inside a product rule. So let's get started. Now the first thing you might want to do, if you have to, is rewrite this function as x squared times that quantity to the 1/2. I'm not going to write it like that, but you can if you want. Okay, so here we go. Maybe I'll do two different colors. We'll do the first in blue, and we'll do the second in green, so you can keep track of what I'm doing. Alright, so I'm going to use the product rule and go derivative of the first, and then times the second, and then plus the derivative of the second times the first. Now, what I'm going to do, because it's quicker, is I'm just going to throw the first in here, and then I'm going to do the derivative of the second, just so that I don't forget to put the first in whenever I'm done, because the derivative of the second takes a little longer. I'm going to use the chain rule, or the general power rule. The general power rule says you want to bring the power down times the quantity to the 1 less power times the derivative of the quantity. Alright, now let's simplify this a little bit. Kind of a lot, that's why it's in this section. Alright, so the first thing to notice is that the 2 and the 2 cancel. And now I also have an x squared and an x here. So I'm going to be putting everything together. This first term I'm going to leave alone. But the next term, let's see, so everything was positive, so I'll have a plus. This times this gives me, oh wait, this was a negative. I almost lost it. The derivative of negative x squared was a negative 2x. Okay, so we're going to want minus x cubed, again that's this term times this term, over the square root of 1 minus x squared. Because since this had a negative exponent, we wanted to move it to the bottom. Alright, now what do we need? We need a common denominator. This needs the square root of 1 minus x squared, so if the bottom needs it, then the top also needs it. And when you multiply a square root times itself, this times this is just going to be the quantity. So we have 2x times the quantity 1 minus x squared minus x cubed, that's from here, all over the square root. And in the last step, since I'm almost out of room, I'll do both of these in one step. It's going to be 2x minus 2x cubed and then minus x cubed. So combine your x cubed terms, 2x minus 3x cubed all over the square root of 1 minus x squared. So go back through any parts of this that you may not have gotten. Alright, some other types of functions, they might not be algebra. Here are the trig functions. You already know that the derivative of sine x is cosine x. Well, what's the derivative of x? It's 1, right? So what you never really realized is that you were really using the chain rule whenever you were finding the derivative of sine x. We just didn't have to write the 1. But if you have something like sine of x squared, then its derivative is going to be cosine of x squared times 2x. And then all of the rest of the formulas follow from the regular derivatives of these trig functions. Here are the last two trig functions. So again, if this was the secant of 3x, then its derivative would be the secant of 3x times the tangent of 3x times 3, the derivative of the angle. So here's your cosecant rule. And lastly, you have the derivative of e to the u. I think I even used this in the very first video. So the derivative of e to the u is e to the u times the derivative of the u. Okay, so let's use these. The derivative of sine 2x, I'm going to leave some room in front of it. It's the cosine of 2x times the derivative of the angle. You always, with the chain rule, have to multiply by the derivative of this. The derivative of that is 2, so it's multiplied by 2. Alright, try the next one. You should be doing a lot of pausing in the video to see if you can do these yourself before you watch me do them. But again, the derivative of cosine of x minus 1 is negative sine of x minus 1. And then we have to multiply by the derivative of this, or the derivative of this, I guess I should point to. But the derivative of x minus 1 is 1. It's the coefficient of that. So we actually already have our answer, because when we multiply by 1, it doesn't change it. And the last one, again, this is probably even a lot easier than the one that we did in the very first video. So the formula for the derivative of e to the u is u prime e to the u. So u prime is 3, then e to the u is exactly what you started with. And other than that's not a good looking x, we're done.